For today's warm-up, you can try and complete this in the connections of your notes or just think about it. Can you find an ordered pair x comma y that is a solution to both of the equations below? X plus y equals 5 and x equals y plus 1. Go ahead and pause the video and think about what numbers you could use for x and y that would work for both equations. Did you come up with 3 and 2? Well, if x equals 3 and y equals 2, 3 plus 2 equals 5. And again, if x equals 3 and y equals 2, 3 equals 2 plus 1. Today's essential question is, how can you solve systems of linear equations by graphing? Let's first talk about what a system of linear equations is. So if you look at the definition, it says a system of linear equations is a set of two or more linear equations in the same variables. An example is shown below. Equation 1 is y equals x plus 1. Equation 2 is y equals 2x minus 7. So a system is always going to have two or more linear equations. A solution of a system of linear equations in two variables is an ordered pair that is a solution of each equation in the system, similar to what we just did in the warm-up. The solution of a system of linear equations is the point of intersection of the graphs of the equations. So what they're saying is, if you were to graph these two linear equations and see where they cross, that point where they intersect is called the solution to the system of linear equations. Here's a set of steps in your key idea that explains how to solve a system of linear equations by graphing. Step 1, graph each equation in the same coordinate plane. Step 2, estimate the point of intersection. Step 3, check the point from step 2 by substituting for x and y in each equation of the original system. Let's take a look at how we can do this. So in example 1, it says solve a system of linear equations by graphing. Solve the system by graphing. You have equation 1, which is y equals 2x plus 5, and equation 2, which is y equals negative 4x minus 1. So let's graph both of these using the knowledge that we already know. I'm going to go ahead and use my y-intercept of 5 here. So I'm going to count 1, 2, 3, 4, 5, and I'll put a dot there. Okay, and then I know that my slope is 2 over 1. So I know it's kind of hard to count up here, 1, 2 over 1. It'd be about there, right? But if you were to pretend that this was a negative 2 over negative 1, you could also count down 1, 2, and to the left one. So now I have enough dots to go ahead and draw a straight line through my dots. Okay, as straight as possible and as long as possible, because you don't necessarily know where they're going to cross, right? I'll start here. So you want to extend that line as long as possible, right? Then I want to go ahead and graph the second equation. So I'll choose a different color to do that. And I'm going to start at negative 1. That's my y-intercept. And my slope this time is negative 4 over 1. So I'm going to count down 1, 2, 3, 4, and over 1. It's about there. Okay, or I can make it a, I could also assume that this is going to be 4 over negative 1, so that would be up 4. 1, 2, 3, 4, and over 1. Some of you guys already see where the lines actually intersect, but let's go ahead and complete our graph. We do need to go ahead and connect our dots to make a very straight line. And now we can go ahead and write down the ordered pair of where they cross. So I know that they're going to cross here at the point negative 1, 3. So the solution to the system is negative 1, 3. Okay. Now if I were to plug these numbers in, so here's my x is negative 1, and my y is 3, I should see that the equations work out. So let's try it. 3 equals 2 times negative 1, plus 5. I'm plugging it into the first one. That's going to be 3 equals negative 2 plus 5. That's going to be 3 equals 3. So great. We know it works for the first equation. Let's plug it in for the second equation. I'm going to go ahead and do 3 equals negative 4 times x. So we know x is going to be negative 1 minus 1. Let's go ahead and simplify. 3 equals negative times a negative is a positive. And we know that 4 minus 1 equals 3. So our solution is correct. It works out for both equations. Okay? So all we're doing is we're graphing both equations. We're seeing where they cross to figure out our solution. Go ahead and try number 1, 2, and 3 on your own. So pause the video and give it a try. So here, if you were to graph these two equations, you would start with a y-intercept of negative 1 and a slope of 1. So that's going to be here. You can keep going, put as many dots as you want. And of course, you're going to connect your dots with a very straight line. And I think I'll start way over here. I happen to know it's going to go through all those points. Okay, and then we're going to do it again for the second equation, where you start with a y-intercept of 3 and a slope of negative 1. So y-intercept of 3 would be here, and a slope of negative 1. You go down 1 over 1 would be here, and again connect it with a very straight line. Oops, that was not a very straight line. Let me get my straight line. And I'm going to see where they cross. Again, it looks like it crosses here. Nice and perfect for us at the point 2, 1. So your solution is at the point 2, comma 1. And again, you should be checking by plugging in your x values and y values into each equation to see if they're correct. Go ahead and pause the video and give number 2 a try. Okay, this time I think I'm going to scale the graph by 5s because we need to start with a y-intercept of 14. So 5, 10, 15 is here. 14 is going to be right around there, okay? And then I'm going to go down 5 and over 1. So that's about here and here. I know it's going to be kind of hard to do when you're estimating, but that's why you would plug your dots in to double check to see if they are correct. So when I connect my line, it's going to look something like this. Okay, and I'll just extend it out so that we have a very long line. And then we're going to have our y-intercept of negative 10. So again, we're counting by 5s. So down by 5, 10. A slope of 1. So that's tiny though, because we're counting by 5s. So you could always just do up 5 over 5, right? Because 5 divided by 5 reduces to 1. So up 5 over 1. Up 5 over 5. Let's go ahead and connect our lines. Make a very straight line. See where they cross. The problem is we're going to have to estimate where these lines cross. Where do you guys think it's crossing right now? It could be around 10, 3, 10, 4. What do you think it is?